My name is Alex Heinrich. I'm a mechanical engineering major.
I'm Jake Brucken. I'm an electrical engineering major. Over the last few days, I've been building a canoe.
You know, I've never done anything close to this. So it's definitely something new and challenging.
I have a friend of mine who goes to Cedarville, and he mentioned that only engineers are able to go on the lake, and I'm like, oh, whoa, that's cool. One of the main parts about our boat is it has a lot of reinforcements, different structures.
Our advisor helped us a lot with that, and then we really wanted to keep in mind, like the boat wanting to twist, because he's leaning to the left and I'm leaning to the right, and so because we're both heavy men, like the boat's going to want to twist. And so we really took that into account for our design. If the boat does start to bend, that means that there's already been a critical failure. The water would probably just start rushing in, and then we would sink. Our advisor recommended that we paddle on the same side the whole way across. So I'm paddling on the right and Jake's paddling on the left. And so we knew that if we're leaning this way and he's leaning that way, that our boat's going to want to crush itself. But if that was to happen, then my side would start to go to the right, Jake's side would start to turn to the left, and our boat would basically, the front right corner and the back left corner would want to touch. When it twists, they're going to get closer together, and so it would basically kind of fold us up like this. If you think about like crushing a can, if you twist a can and push it together, that's kind of what it would do. We have 4 or 5 different individual strong pieces that are designed to not let it do that. Most teams, I think, put a single bar in the middle and the top to prevent their boat from twisting, and like some X's at the bottom. What we did is, because we know which way our boat's going to want to twist, we only focused on preventing it from twisting that way, which I think helped us save cardboard and tape. But what we did is we put the bottom of our boat looks like 3 Z's stacked on top of each other, and then at the top we have 2 individual pieces that lay like this to prevent it from twisting. Like if the boat body's this way, it lays like this. It's like slightly diagonal, which will help with the boat wanting to twist corner to corner.
To keep it from bending like this, all our weight is going to obviously be towards the bottom, so we have different support structures that are pushing that force out and up.
For our sides, to keep the sides from like collapsing in. We've got those 2 diagonal bars, but a lot to do with bending is how strong the sides can hold up, like push against the back walls to prevent them from wanting to come like this, which would cause the bottom to sink out. We have we have a big support on each side like this that helps like pull and push at the same time. And then we also have where we kneel, very thick rolls of cardboard that we put our knees and our feet on, which help distribute the weight evenly amongst the main frame of the canoe, and making it so that it's like not as difficult for the boat to hold us up. Ben, another guy on our team, put everything into a spreadsheet and then put it into a software. I've done some woodworking in the past, and I know that just from my woodshop teacher that woodworkers use software like this all the time for when they're making a lot of cabinets to figure out how to maximize the use of their plywood so that they don't have to get more than they need. I was like, oh, I wonder if that program exists. I'm sure it does. Ben looked it up, and sure enough, he found one that worked. He can give it like the material, like size, and it tells him where each piece should go to maximize the use of our cardboard.
So an idea we had was we have a 3/4 inch copper pipe, diameter, and we cut a slit through it. So what we can do is actually take the cardboard and put it into there, and then when we go to roll it, then it'll like stay in place and be really tight. So in most boat keels, you have they come together like this, or they might be rounded, so it'll either cut through the water or it'll just bounce over the waves. We want the water to just kind of go around it and go under it instead of having to literally push against the boat.
Yeah, well, I had the original idea for the front end, which was the part, the key feature. I had the idea, and I was like, oh, I think that'd be really good. And then from there, we just kind of applied our, weight to figure out our sink depth.
Rather than having suggested by maybe like TK Silver, 12.5 inch for our height. We moved it to like 15, I think.
15.
Yeah, 15. So, because in total we're gonna be like, I think it's 375 pounds.
Something like that, yeah. But for the boat, one oversight that we had, our diameter of our pipe that we rolled around is 3/4 of an inch. And when Ben was doing calculations to figure it out, he didn't take into account the fact that as you roll the cardboard is rolling on top of more cardboard, so it gets thicker. And so for about every roll around, we lose about a 1/2 inch. So our bottom supports, which were originally supposed to be 3, are now like 2.5. That's a little bit scary because like you can bend them a little bit if you try, and I know that my 200 pounds is definitely going to want to bend those. So the rest of the boat seems pretty solid. That's the only thing that I'm pretty nervous about is how well those will hold up. I'd say it took about 6 hours for the design and everything total. That's just as a team.
Yeah.
Like individually, Ben, I know, did all the calculations to figure out like the length of supports that we need. So the design, all in all, I would say it took probably about 6 or so hours, and then for building, 12 hours now. I think maybe a little bit more than that. We tried. I think as a team, we tried to make every decision unanimous in a sense, like I guess majority rules in a way. We definitely just tried to make sure that everybody was okay with the decision that we were making, and we all thought it was a good idea, rather than one person being the designated leader who made all the decisions. Figured 4 engineering minds is better than 1.
Yes. I'm pretty excited for the race. I'm excited to see how this goes.